welcome to Rayfi Academy. I'm Cordelia,
And I'm Maxim.
and we're here to talk about how to create databases in Dark. So it's pretty simple. This is the canvas or the integrated web IDE, integrated development environment. And so to do so, you simply click this plus here, or you click anywhere in the canvas. So we're going to create a restaurant, a database of restaurants. So I'm going to click and then go restaurants, if I can spell it right. Yeah, there we go. And actually, let's do lowercase. Okay, and then I'm going to click enter, and then wonderful, we have our database. So we have a DB field name and DB type, which is the data type. So these are the different fields. So what do restaurants have? Restaurants have names.
I think we have titles, the name, the location,
Okay.
and then we have a delivery charge.
Okay. So name, title. What is title?
That's the name, I think. Then we had location, where it's located.
Location.
So we'll specify something like.
Should location be an array of strings, or like this, or should
there is a dictionary type. So dictionary type in Dark, like in many other languages, is essentially like an object. So we can put any kind of things there, and we can put like flat, long for the exact coordinates, and then have a address there.
Okay. So we're going to choose dictionary for that, and then we need, what's the delivery charge?
Yeah, delivery charge.
And then we're going to use an underscore and delivery, if I can spell charge right.
Yeah.
And then delivery charge should be a dictionary?
That's probably the float, because we're going to be like, it's just a number, right? And if we choose integer, then we won't be able to do the sense, so it's better to use float.
Okay, that makes sense. I don't think we need anything else.
Yeah, that's good for restaurants.
Yeah, so let's create, I'm going to go over here and use the plus so people see what that looks like. And let's create a products or a menu items. We're going to call it menu database. And notice how it automatically created a name and then I had to delete it. In this way, it's easier to do that. And notice how the name is still over here and it's not here. It doesn't rename it until I click out. Okay.
Yeah, until you press enter.
Yeah. Click out, press enter. Yeah, That makes sense. Okay, so what fields does this have? Fields, it probably has some sort of name. And string, and then it has probably tags, or the types of things it goes.
Yeah, the tags essentially will allow us to set up any structure that a person wants. So like set them by categories or by the types or whatever they want. They just set that string tags of like, let's say this is, I don't know, lunches or specials or whatever, and then the visual display will determine how to show it on the screen, right?
Yeah, and so this means that it should be an array of strings, is that right? Or it shouldn't be a dictionary?
Yeah.
Okay, all right.
It's easier to do with an array of strings because we don't necessarily have, like dictionary would be more like where we have specific things like this is just many different strings of saying this is labels, essentially. You can think of it as like Gmail labels.
Yeah, that makes sense. Should we store cost here? Or price?
Yes, the cost of the price, yeah.
Okay, so that's going to be a float because that's a thing. And we have the name of the item, the tags, the price, and we need to figure out which restaurant it goes into.
Yeah, so we can use just the restaurant ID field.
Yep.
And if you've ever done any other databases, it is not the same as SQL database, so you don't link them directly. We would literally just put the string there, and then we search for it when we make a query.
Yeah, and notice how we're not creating like an ID field in each of these, like I would normally do. It automatically creates that, I think, right?
Yeah.
Right. All right.
Yeah.
So, yeah. Because otherwise because when I was first doing this, I was creating like ID and then they have a UUID type.
Yes,
That's
that's a bit of confusion there. They basically create they would create ID automatically for you for every field, so you don't need to create this column yourself.
yeah. Okay, so that's a menu, I think.
Yeah.
And the only other thing I can think of is menus may have different types, like entrees or appetizers.
That's the tags essentially.
Okay, so that would be a tag as well. Okay.
Yeah.
Yeah. Okay. I think we've got our schema right.
Mm-hmm.
Okay, let's create another one. Let's create one for orders.
Mm-hmm.
So let's go new DB, and let's rename this to orders. Apparently, I'm just.
Apparently, sometimes it's outside. Yeah.
I know.
Okay, so we have with orders quite often when you use like a relational database, you would set up a hierarchy, but because it's not a relational database, you don't necessarily want to do this here. And we have a dictionary, so we can kind of do array of dictionary to store the items that we want to have inside the order.
Yeah. So items and then array of dictionary.
Yeah.
Okay. Great. And then we should have the restaurant, which would be a string.
To be consistent, I would say maybe we'll call this restaurant ID, so that it's the same.
Yeah. Well, I'm thinking there might be a customer ID that we might want to do, or something like that eventually too.
Yeah,
so
but if you want to store customers separately, so you have restaurant underscore ID, and then next field can be the customer ID. I would say for now what we can do is just store customers in dictionary.
Yeah. Okay.
And then put all the fields there for the customer. The location, do we want to store separately? Where to deliver?
I was thinking destination. Yeah.
Yeah, the destination. Yeah.
And I'm gonna call that a dictionary, and then we need to do order time, or just do time, something like that, and then we'll do date. Now, one of the things that was confusing to me is that it unlike like certain other things, this is actually a date time object, not just a date object, despite its name.
Yeah,
date.
it has both the time and the date. So when we use dictionary, one thing to keep in mind is that we are losing a bit of type safety there, because our records in theory can have different structure because it's just a dictionary. So that's probably for that case is fine, but if you want to be more robust, you want to like do the references instead. So have your customer ID, have a separate table for the customers, and then look them up or create a new one depending on what the case is. But I would say for like a simple scenario, that's most of the time is more than enough to do this.
Is there going to be a performance hit by using an array of dictionary here rather than like some other ID, some other?
You're most likely going to get more performance hit if you're accessing multiple tables. It's because the database essentially is the same as the Firebase. So in Firebase, you don't have linkages between the tables. So when you need to query a table many times, it is slower than caching things in one table. So most of the time, especially for orders, when order items, they don't exist outside of orders. Like they're only relevant when you have order itself. You don't really care if the order item by itself. It's not a good example for the reference table, but the customer might be a good example for that, where let's say it's the same customer, we want to then figure out like that specific customer, what are they orders for that specific customer, right? Then we would need to look them up somehow, and if they don't have an ID, it's going to be a bit of a problem.
I mean that makes a ton of sense.
Yeah, but I think those like, because we're doing the simple use case, so you customize this to however what is your use case. We just want to show you how to do it simple, and then you model from this and you add whatever fields you need on top of that.